Dear colleagues, today I will present you my software GeoSpring 1.0. So this software was developed for the design of shallow and deep foundations. As you see, the development of such a product has started since 2015. So today we will see the futures of GeoSpring in the design of shallow and deep foundations. So let's go ahead. Basically, GeoSpring, it contains 4 modules. The first module, it's about the design of shallow and deep foundations. So it computes the bearing capacity and settlement. The second module, it's about pile foundations. So it computes the settlement of pilot foundations, single piles and group of piles also. The third module, it's about the design of rigid enclosures. And the final module, it's about the settlement of embankments. So the short-term and long-term settlement of embankments. So today we'll see the design of deep foundations by the means of GeoSpring. So we'll see the computation of the bearing capacity and settlement of single piles. And then we'll see the estimation of bearing capacity and settlement of the given group of piles, arbitrarily distributed, no restriction on the coordinates and no restriction on the number. Okay, so let's start by estimating the bearing capacity of single piles. After that we'll go to settlement, and after that we'll go to the settlement of pile group. Okay, so the bearing capacity with GeoSpring of single piles can be estimated through the wafy method, based on the cohesion and friction angles of the layers crossed by the pile, and also by pressure meter data. Okay, so let's start, for example, bearing capacity, drained load capacity. So here you put the name of your project, task bearing capacity of single piles, and your client. Here you will put the pile geometry. Okay, let us say, for example, 0.6. Let us say that the length is equal to 17, the water table is at 2 meters, and our safety factor is equal to 2. Here we can put the thickness of each layer. Okay, and here we will put the density of each layer. Here the cohesion. For example, let us say that all the cohesion in this case are equal to 0. The adhesion factor, of course, it's a factor that we multiply by the cohesion to estimate the shaft capacity. For example, for bored piles, the adhesion factor is equal to 0.5. Okay. Here we put the friction angle of each layer. For example, 25, 27, 27, and for example 33. Here the friction coefficient, which is equal for the case of bored piles to 0.66, and such a coefficient varies between 0.3 and 0.75. So here the friction coefficient. Okay, so after putting all this data, you push on the button and you get the shaft term, the tip term, and the load capacity corresponding to the factor of safety that you put it. For example, if you put safety factor of 1.5, it will just recombine and give you the new load capacity. Okay, so let us move right now to the estimation of the bearing capacity by means of pressure meter data. Okay, so in the pressure meter method you have 3 codes to estimate the bearing capacity of single piles. You have the DTU 13.2, the fascicule 62, and the Eurocode 7. Let us say that we'll estimate the bearing capacity with DTU. Okay, for example, DTU here, and let us go for example to board piles. Okay, so here you will put the geometry of your pile. Okay, for example 0.8, the length for example to 12, and Kp equal to 1.1. so the burying factor Kp depends on the pile execution process. When we have compaction task or a driving task, the value of Kp will be higher than 2, and when we don't have driving process or a compaction task, the value of Kp will always be lower than 1.6. So here you put the type of your layer, for example clay, and for example sand. Okay, so you put here 3 example, and here 3, and here 2 for example, and here 5. Okay, so here you put your limit pressure profile, for example 7, 7, 7, after that 9, 9, 9, 11, 11, 11, and after that it goes to, for example 15, 15, 15, 15, 15. After inserting your limit pressure profile and your geotechnical cap and the geometry of your pile with the burying factor, you push on the button and you will have the shaft term, the tip term, the burying capacity at ultimate limit state, and the load capacity, the burying capacity at service limit state. Here you have more detailed data, the thickness of each layer, the arithmetical and geometrical mean of the limit pressure, and here you have the shaft term of that each layer develops to compose the total shaft capacity. Okay, so now let us move to the settlement of single piles. So you go to single piles settlement. So you have the settlement of single piles in GeoSpring by means based on cohesion and friction angles, and also based on pressure meter data. Okay, so the settlement by means of cubic root curves. Cubic root curves are load transfer curves which engineers use to estimate the load settlement curve of a single pile, okay, based on cohesion and friction angles. So the load transfer method is commonly used in practice to estimate the settlement of single piles. So here you put the task, for example settlement of single piles here. Here you put your client. Okay, so here you put your pile technology, for example board piles, the diameter of your pile, for example 0.6, the length, let us say 20, and the soil models at the tip, let us say 35 MPa. Here you put the thickness of each layer. Here you have the unit weight of each layer, cohesion and friction. Okay, let us say that we are always in sand. Okay, so to make things faster, 30, 33, 33. Okay, so just here you push on the button, and here you have two curves. You have the load settlement curve of your pipe. Okay, so this load settlement curve will allow you to verify if your service limit state load capacity corresponds to a feasible pile displacement, pile settlement or not. And also you have here the evolution of the vertical force as a function of the pile depth. So this force at the pile head corresponds to a settlement of the pile equal to the diameter of the pile divided by 100 to be in harmony with the recommendations of Eurocode 7. Okay, so now let us move to the settlement of pile group. So piles group settlement. So here you will put the coordinates of your pile. For example, let us say that we have 4 piles, so 0, 0, 0, 2, 2, 0, and 2, 2. Okay, here you put the thickness of each layer. Okay, and here you put your cohesion and friction angle, and here you put your density. Okay, your unit weight. For example, 22, 25, 27, 35, 35. Here you put the diameter of your pile. Okay, for example, 0.6. Here you put the length of your pile. For example, 20. The water table and the soil models at the table. 45 MPa, for example. Okay, and you confirm that the number of your pile is equal to 4. Okay, so you put 4, and here you put your applied force, and here you put your pile technology. Okay, for example, CFR piles. Okay, and you push on the button to obtain the load settlement curve of your pile group. So this is the load settlement curve of your pile group, and this table summarizes the data that gives you in the first column the load, the vertical load, and its corresponding settlement. So thank you very much.